Today we'll be discussing a topic called momentum. For example, now if you have a movement from one point to another, you discover that you have undergo what we call velocity, because velocity is the rate of change of distance, displacement with time. And you have a mass which you use in doing that movement. It gives you an idea of what momentum is. We can now define momentum as the product of mass and velocity. See after me, the product of mass and velocity. It implies that momentum can be denoted by the letter P, and we can say that momentum is product of mass and velocity. And if it's a product of mass and velocity, it has an SI unit. So from this equation, we can be able to derive the SI unit for momentum. M, which is mass, is in kilogram. V, which is velocity, is meter per second. Therefore, the SI unit for momentum is kilogram meter per second. Or it can be written in this form again, or kilogram meter per second. Now, momentum is a vector quantity. Why is it a vector quantity? Because it has both magnitude and direction. And it is taking the direction of the what? Velocity. So therefore, we are looking at momentum as a vector quantity. It has both mass and velocity. Now, there is something we need to look into which we call impulse. Impulse is denoted by the letter capital I. Mostly people denote impulse with I. And impulse is the product of force times time, which is I is equals to Ft, where F is force and T is time. And from there, we can also derive the SI unit for impulse, which F is in Newton, while T is in second. So therefore, impulse has an SI unit which is Newton second. And impulse has an SI unit which is Newton second. And also, impulse is a vector quantity. And the SI unit for this, if we say impulse is a vector quantity, we know that F is equals to ma, and the direction is in the direction of what? Acceleration. For example, now let's take a little question and solve something. If we say a body of mass 3.0 kg moving with a velocity of 10 meters per second, calculate the momentum of the body. It implies that, first of all, to solve any question, you need to understand that you need to itemize the variables. First of all, they gave us a mass of 3.0 kg and gave us a velocity of 10 meters per second. Now, they ask us to find the momentum. Therefore, we can go further to say that P, which represents our momentum, can be mass velocity, which will have 3.0 times 10, which will give us what? 30 kilogram meter per second. Now, this one is the answer for this question. Now, there is a relationship, there is a law which Isaac Newton states, and it is called Newton's law of motion. And in this law, we have the first law, the second law, and the third law. And before we go into the third law, the second law gives us a relationship between momentum and impulse. But we'll be able to define the first law of Newton as we go further to explain the concept of momentum better. First law, Isaac Newton states that a body will continue at its state of rest or uniform motion in a straight line unless it is acted upon by an external force. Mathematically, we can draw an expression to explain this concept that if this is a body, a football on a straight plain field, and this ball will continue to be at its state of rest. This is what Isaac Newton is saying, that this ball will continue to be at this state of rest until an external force is applied. An external force is applied to this body. Once an external force is applied, it keep moving, it keep moving, it keep moving. From this point, it keep moving. That is what we call uniform motion in a straight line. Unless another external force is applied to put the body to stop the movement. This was what Isaac Newton explained as Newton's first law of motion. Newton's second law of motion. Now let's look at Newton's second law of motion. Newton's second law of motion. Now, the law states that the rate of change of momentum is directly proportional to the applied force, and it takes place in the direction of the force. The law can be stated in mathematical expression that the rate of change of momentum, this is called change of momentum, directly proportional to the applied force, and it takes place in the direction of the force. So this is what we call Newton's second law of motion mathematically, which is stated that the rate of change of momentum is directly proportional to the applied force, and it takes place in the direction of the force. And this sign you see is called proportionality sign. To remove a proportionality sign, you introduce what we call proportionality constant, which is F is equals to K into mv minus mu all over T, where K is equals to 1. It implies that F is equals to K. It implies that F is equals to mv minus mu all over T. This further explains that we know that if we say that F is equals to mv minus mu all over T, it implies that this we can make simplicity that F is equals to m, since m is common into this, into v minus u all over T. And we know that from the definition of acceleration, acceleration is the rate of change of velocity with time, which is v minus u all over T. And this will give us, if we substitute this into this, we now have F is equals to ma. You discover that this is the formula for force. You see that Newton's second law of motion has given us a formula for force, which force is equals to mass acceleration, the product of mass and acceleration. This Newton's second law also gives us the relationship between momentum and impulse. Now, if we say the relationship between momentum and impulse, it implies that if we cross multiply, Ft is equals to m v minus mu will give you this. So it therefore shows that this is what we call impulse by definition, because we said impulse is the product of force times time and momentum. So it implies that impulse is equals to change in momentum. So this Newton's second law can give us a relationship between impulse and change in momentum.